My name is Nina Human, and I'll be giving an overview on hematopoiesis and the production of red blood cells. Hematopoiesis is the process in which mature blood cells are created from a stem cell. A stem cell is just a cell that has the ability to create multiple different types of cells. For hematopoiesis, this cell would be a hemocytoblast. It has the potential to make a megakaryotoblast, which turns into platelets. It can make red blood cells or any of the 5 white blood cells. So if blood cells come from hemocytoblasts, where do hemocytoblasts come from? Well, they're made in the bone marrow and they're derived from mesenchyme cells. Mesenchyme cells are derived from mesoderm, which is one of the 3 germ layers of an early embryo. If you observe this figure, you see the different components of the blood. Plasma makes up approximately 55%. It's mostly water and dissolved solutes. Erythrocytes makes up about 45%. It's red blood cells that function to transport oxygen. And this small layer is less than 1%. It represents the buffy coat, which are white blood cells, and the platelets. A red blood cell is formed from a myeloid stem cell, a descendant of a hemocytoblast. The myeloid stem cell turns into a proerythroblast. At this point, that cell cannot become anything other than a red blood cell. From the proerythroblast, it becomes an early erythroblast that does a lot of ribosome synthesis during this time. The next phase is a late erythroblast. It is accumulating a lot of hemoglobin. From the late erythroblast, it becomes a normobblast. It's still accumulating the hemoglobin and begins ejecting its organelles, eventually ejecting the nucleus and taking on that biconcave shape. It then becomes a reticulocyte. It's an erythrocyte that still has the ribosomes, and eventually those ribosomes will be eliminated and will become a mature erythrocyte. Okay, now I'm going to take a closer look at all the steps of erythrocyte production. So during the first stage of the development, it is accumulating it's synthesizing a lot of ribosomes. This is important because ribosomes is what synthesizes proteins, and hemoglobin is a protein in a cell that's very necessary for carrying O2. Also, the hemoglobin plays a big part in maintaining the shape of a red blood cell. A red blood cell shape is very important because it's ideal for carrying oxygen. It has a large surface area to volume ratio, and because it has the biconcave shape instead of being spherical, it at no point is anything in the cytoplasm too far from the surface. The body must maintain a certain level of erythrocyte content in the blood, otherwise the body will have difficulty getting enough oxygen to all of its tissues. So after someone donates blood or gets cut, how does the body know to replenish that lost blood cells? Well, it begins with something called HIF. It's hypoxia-inducible factor. It alerts hundreds of transcriptional targets to low O2 conditions. So it will alert the body to slow down metabolism, glucose uptake, and angiogenesis. One of those things that it alerts the kidney cells that release erythropoietin, or EPO, to release more erythropoietin. Erythropoietin works to stimulate cells in the bone marrow that have already committed to becoming red blood cells and accelerates their maturation so they're able to be produced at a quicker rate. People with kidney disease, such as polycystic kidney disease, often have difficulty creating and releasing enough EPO and are therefore often anemic.